Hello viewers, now welcome to the third lecture on this linear algebra course. Now in this lecture we will solve some of the examples using the Gaussian elimination method. In previous uh, video we saw the row picture, column picture and how to solve equations using Gaussian elimination method. Now here in this lecture we will solve three problems using Gaussian elimination method so that it becomes very clear to you how to solve this, how to solve the pair of equations using Gaussian elimination method. So let us take our first example. Our first equation is 2x plus y equals to 0. Our second equation is x plus 2y plus z equals to 0. Third is y plus 2z plus t equals to 0, and last one is z plus 2t equals to 5. Now all of our these examples are taken from the book Linear Algebra, which is written by Gilbert Strang. So you can find these questions in that book. Now let us solve our questions. Here you can see we have four variables: x, y, z and t. So first we will eliminate x from our second equation. We don't have x in third and fourth equation, so we don't need to do that operation. Similarly, we need to eliminate y from our third equation and then z from our fourth equation. So this is a simple example. So what we will do is we will take this equation 2. We will denote by R2. Now what we will do in R2 is that we will subtract R2 with half times of R1, that is 1 by 2 times of R1. So what this will do is, so 2 times of, so we will have half of R1, that is 2x plus y equals to 0. So this will be x plus y by 2 equals to 0. Or what you can do is that you can subtract R2 by taking 2 times of R2 minus R1. So any operation can be done on these equations. So this time let us do our second part, that is what we will do is 2 times of R2 minus R1. So multiplying it by 2 times we get 2x plus 4y plus 2z equals to 0. Now we have to subtract R1, so that is 2x plus y equals to 0. Subtracting this part we get 3y plus 2z equals to 0. So what our second equation become is 3y plus 2z equals to 0. So let us write our modified equation here on the right hand side. As we modify, we will write our equations on the right hand side. So our first equation will remain same, that is 2x plus y equals to 0. This will be equals to 0. Second equation becomes 3y plus 2z. This is now equals to 0. Now we will modify our third equation. Now for R3, what we will do is we will take this equation and then subtract it from this equation R3. So our operation will be R3 will be equals to R3 minus, this will become one third of R2. So the coefficient of y will become same. So what this will become is that y plus 2z plus t equals to 0. and then this equation will be y plus 2z by 3 equals to 0. Now we can subtract it. So this will be again 2z by 3 plus t equals to 0. So this will be our modified third equation. So let us write that part on the right hand side. So our equation is 2z by 3 plus t equals to 0. Now our last equation is z plus 2t equals to 5. So what we will do is we will do the operation on this fourth equation. So our operation will be r4 equals to r4 minus 3 by 2 times of r3. So multiplying this equation by r3 by 3 by 2, what we will do is we will make the coefficient of z as 1. So our equation will be z plus 2t equals to 5. This is our r4. Our new equation will be z plus 3 by 2t equals to 0. Now we subtract these equations. So what we will get here is t by 2 equals to 5. So the value of t. So this will be our fourth equation. So we can write our fourth equation here. This is t by 2 equals to 5. Now we have done the forward elimination part. Now we just need to do the back substitution. So our set of equations moved from this portion here to this portion. Now we just need to do the back substitution. So our t will become 10 as it is 5 times 2. Our second will be 2z by 3 plus 10 equals to 0. So our z will be minus 15. Similarly, you can back substitute it here. So what you will get is y equals to 10, and then again you will put it here. So x will be equals to minus 5. So in this way you get the answer for this set of equation using Gaussian elimination. Now let us see our another example. So this time we are taking 3D equations. So only three variables will be there. So our first equation is u plus v plus w equals to 2. Second is u plus 3v plus 3w equals to 0. Third is u plus 3v plus 5w equals to 2. Now we will eliminate u from equation 2 and 3, and then v from equation 3, and then we will do the back substitution part. So our operation will be r2 equals to r2 minus r1 as the coefficient is same, and r3 equals to r3 minus r1. So let us do our first operation. It will be u plus 3v plus 3w equals to 0. This is u plus v plus w equals to 2. We subtract it, we get 2v plus 2w equals to minus of 2. So this is our second equation. So our new equations that we get is u plus v plus w equals to 2, 2v plus 2w equals to minus of 2. Now let us do our third equation. So it is u plus 3v plus 5w equals to 2, and u plus v plus w equals to 2. We subtract this, we get 2v plus 4w equals to 0. Now the portion that we need to remove is the v variable from our third equation. The coefficients of v are same, so we will do another operation on the third equation. It will be nothing but r3 equals to r3 minus r2. So it will be 2v plus 4w equals to 0, and then 2v plus 2w equals to minus 2. We subtract it, we get 2w equals to 2. So our last equation becomes 2w equals to 2. Now we have transformed our equations into this form. Now we can do the back substitution. So this will give us w equals to 1. Then we will put it into the second equation. So it will be 2v plus 2 equals to minus 2. So 2v equals to minus 4. So v equals to minus 2. Now we put this into first equation. So it will be u minus 2 plus 1 equals to 2. So u will be 3. So our answer is u equals to 3, v equals to minus 2, and w equals to 1. So this is our final answer for u, v and w. Now we will see our last example for this lecture. Hope you are getting this, how to solve this Gaussian elimination. So let us take our last example. It is 2u minus v equals to 0 minus u plus 2v minus w equals to 0 minus v plus 2w minus z equals to 0, and then minus w plus 2z equals to 5. So we don't want u in this second equation, v in this third equation, and w in the fourth equation. So we will do the operations accordingly. Now our first operation will be to eliminate u from our second equation. For that we can do here is r2 equals to r2 plus half times of r1. You do half times of this r1, you get u minus v by 2. Then you can add these two equations to eliminate u. So our operation will be minus u plus 2v minus w equals to 0, and then u minus v by 2 equals to 0. You add these two equations, you get 3v by 2 minus w equals to 0. So our set of equations are 2u minus v equals to 0, then 3v by 2 minus w equals to 0. Now we will eliminate v from our third equation using this equation. Our equation is minus v plus 2w minus z equals to 0. So this is 3v by 2 minus w equals to 0. So the operation that we will do is we will multiply this by 2 by 3. So this will become v minus 2 by 3w equals to 0. So now we will add this to this equation. So v minus 2 by 3w equals to 0. As soon as we add this, 6 minus 4 by 3. So this will be 4 by 3w minus z equals to 0. So this will be our third equation. The operation that we did here is r3 equals to r3 plus 2 by 3 of r2. Let us write our third equation here. So our third equation is 4 by 3w minus z equals to 0. Now we will use this equation. Now we will use this equation to eliminate w from our fourth equation. So for this, what we will do is multiply this equation by 3 by 4th. So our operation will be new r4 equals to r4 plus 3 by 4 times of r3. So this will be minus w plus 2z equals to 5. Multiply this by 3 by 4. So you get w minus 3 by 4 z equals to 0. You add these two equations. 5 by 4z equals to 5. So last equation is 5 by 4z equals to 5. So now we have now we have done the forward elimination. All we need to do is do the back substitution. So we go from bottom to up. So our 5 by 4z is equals to 5. So the value of z is 4. As soon as you put z equals to 4 in equation 3, it is 4 by 3w minus 4 equals to 0. So w is 3. Similarly, you do it for equation 2, you get v equals to 2. Now you do it for equation 1, you get u equals to 1. So our answer is u equals to 1, v equals to 2, w equals to 3 and z equals to 4. So this is our final answer. So in this lecture we saw how to apply the Gaussian elimination. In all our examples we have not included a singular case. For all the examples we got the answer for our variables. Now in next part we will see the singular cases, and this will make linear algebra more interesting. So I hope you all like this. You all like this lecture. So please like and comment on the video, so that if you have any doubts or if you appreciate the video. Uh, so that is all in this lecture. So thank you for watching.